Electronic configuration. So electronic configuration of group 13, the boron, atomic number 5, helium, 1s2, and after that 2s2, 2p1. These are the inert gases: helium, neon, argon, krypton, and xenon. So outermost electronic configuration, general electronic configuration is this inert gases, noble gas after 2s2, 2p1, 3s2, 3p1, that is ns2, np1 is a general electronic configuration. Okay, next, ionization enthalpy. How ionization enthalpies are varied. Ionization enthalpy means opposite to atomic and ionic radii. Ionization enthalpy decreases down the group because atomic size is increases. Okay, then the removal of p electron is much easier than s electron. Therefore, the first ionization enthalpy of elements of group 13 are lower as compared to the corresponding elements. This is the because of ns2 np 1 electronic configuration. ns2 np 1 electronic configuration, removal of this electron is easier. After that, inert gas, after that, sorry, not inert gas, the stable electronic configuration, so removal of electron, which will be difficult. Okay, so ionization energy decreases down the group. Okay, in gallium, so slight variation in gallium because of poor shielding or imperfect shielding. There d and f electron, so electron enter to penultimate shell. Due to that, ionization enthalpy varies. This is already we discussed. Next, electronegativity. So electronegativity down the group, electronegativity decreases from the boron to aluminum, then increases after that gallium. This is because the smaller atomic size. Discrepancy means unusual change. Unusual variation in atomic size is responsible for electronegativity. This also we discussed. Physical property we discussed in earlier class about the boron, and it is strong crystalline lattice, high melting point. Leicester further will be low melting point. Boron is extremely hard and black colored solid and non-metallic nature. Other members of the families are soft metal, which low melting point and high electrical conductivity. And in the case of boron, boron in crystalline form, it is inert crystalline form, stable. In amorphous form, it is reactive, more reactive. An oxidation state, it's predominant shows +3 oxidation state. Boron shows +3 oxidation state. Okay, down the group, boron and aluminum shows +3 oxidation state. Down the group, tendency of the formation of oxidation state will be +1. Why? Because of the imperfect shielding. Imperfect shielding, force of attraction increases. So two ns2 electrons are not involving in chemical bonding. That is what we call as inert pair effect. That is what we discussed in earlier. So inert pair effect, so chemical property, I'll tell you what is an inert pair effect. In the oxidation state, there's one variable oxidation state, reactivity towards air, acids and bases, alkalis and halogens. What is inert pair effect? In the p block elements, note, in a p block, as we move down the group, the stability of element in its lower oxidation state increases because due to inert pair effect. Down the group, +3 oxidation state to +1 oxidation state, right? Down the group, from boron and aluminum, will be having +3 oxidation state. After boron and aluminum, gallium, indium, and the thallium in their oxidation state started, and +1, +1, and +1. More predominant oxidation state of thallium is +1. Okay, because in the atomic size increases, in extreme increases, the force of attraction in between nucleus ns2 electron down the group, there will be poor shielding. So from here onwards, gallium onwards, the poor shielding there, here onwards, ns2 electrons are reluctance towards chemical reaction, is nothing but these are not involving in chemical bonding. Due to that, only the outside electron, p1 electron, is involving in chemical reaction. So this more predominant down the group, this gallium is most of +3 and +1 also. Indium, so +1 is more, and thallium maximum, and it shows in +1 oxidation state. Okay, so you know inert pair effect, that is already we discussed in the earlier class. Okay, next after this, reactivity towards air. So we were discussing this in earlier class, previous class, how they react with air or oxygen, the elements group. So we are not writing M. We can able to write M, metal, but instead of that, metal or non-metal, metalloid will be present. So we'll be using symbol E. Element E react with oxygen will be forming E2O3 type of oxide, element oxide. So boron react with oxygen will be forming B2O3. B2O3 triboric acid, triboric oxide or boron trioxide, right? Not a triboric oxide, that is boron trioxide. And aluminum react with oxygen to form alumina, that is Al2O3, aluminum oxide. It's also we call as corundum. Next, gallium oxide, Ga2O3, indium oxide, and thallium oxide. Okay, then nature of oxide varies down the group. We said that the oxides, the property of the oxides also, how what will be its property? What we discussed in earlier class, how the acidic, basic, and alkaline nature, how it will be varies, whether basic nature increases or decreases down the group. Already you studied how it will be varies, oxide, B2O3. Tell me, boron trioxide. Yes, Punit Kumar. It increases down the group. Is nothing but what about B2O3? Yes, you need to tell me. This already we finished.
Basic.
Acidic or basic? B2O3?
Basic.
B2O3?
Basic.
Basic.
Yes, sir.
Hey, what we discussed in last class, man. Then you didn't listen properly, I think so. B2O3, okay, that is acidic, not basic. Is Punit. B2O3 is acidic. Next, Al2O3 and Ga2O3. Al2O3.
Amphoteric.
Yes, Ga2O3 or amphoteric. And In2O3 and Tl2O3.
Highly basic.
That these are basic. So this is what we said. Okay, I think you forgot all these things what we discussed in earlier class. Yes. Next, so reaction towards with aid, or how these group 14, 13 and 14, we need to study 14 later. 13 group 13 elements, react with air or oxygen at high temperature. We need to mention the heat or delta. Heat or mention delta. This is heat or delta. Will be forming A2O3 type of compound. Elemental oxide. Normally, says Al2O3, alumina, aluminum trioxide, normally called as aluminum oxide. Okay, Al2O3. Boron oxide, we call as boric oxide. This boric oxide is boron trioxide, what we call as B2O3. Okay, gallium oxide, G2O3. This is how they react with each other. Are you getting? So this is what we discussed in earlier. I'm saying what we discussed in earlier itself, not the new things. Next, after that, the reaction towards alkalis, acid and bases. Usually, boron not so easily react with acids and bases because of inertness, more covalent nature. Okay, and they'll be forming means the reactivity towards acid and bases is less reactive. So they require high temperature. They require high temperature. In high temperature, boron react with acid as well as base. Acid HNO3 will be forming the boric acid H3PO3 and the nitrogen dioxide NO2. Similarly, it react with alkalis like sodium hydroxide to form Na2BO3, sodium borate, with the liberation of hydrogen gas. With the liberation of hydrogen gas. Not only this, we studied aluminium. Aluminium also react with acid and bases, but slight reactivity is slight low in aluminium, because aluminium forms the protective layer around in it. Al2O3 is aluminium oxide. It forms a protective layer around in it, which renders the chemical reaction, which slow downs the chemical reaction, which prevents the chemical reaction. That is the reason, especially in nitric acid, that is the reason concentrated nitric acid HNO3 is transported in aluminium container. That is the reason concentrated nitric acid will be transported through aluminium containers. This is a point we discussed in earlier itself. Okay. Next, aluminum. So, as like a boron, aluminum react with acid and bases. So, acid and bases, alkalis. So, water soluble bases. Okay, water soluble bases will be forming the same as like aluminum oxide, as like the boric oxide will be forming the respective oxides, right? So, what we discussed in earlier class, aluminum react with oxygen, aluminum oxide. Now, if they react with HCl or NaOH, HCl or NaOH, which can able to form aluminum chloride, aluminum chloride. Okay, when they treat with hydrochloric acid, HCl. Okay, so or which treat with sodium hydroxide. It is also possible to react with sodium hydroxide. So in both the reaction, both the condition within written reaction. Sorry, in last class I hope we discussed the reaction. Aluminium react with hydrochloric acid as well as aluminium react with the base like sodium hydroxide. So aluminium react with HCl, hydrochloric acid, will be forming
Aluminium chloride.
aluminium chloride with the liberation of hydrogen gas.
Hydrogen gas.
And aluminium react with sodium hydroxide, will be forming
Aluminium hydroxide.
sodium tetrahydroxoaluminate with the formation of with the liberation of hydrogen gas. What it forms? No, aluminium hydroxide, AlOH, sodium Na, AlOH 4 times minus. So this is called sodium tetrahydroxoaluminate. Sodium tetrahydroxoaluminate, and within a bracket Roman letter 3. So this is called stock notation. What is stock notation? Its oxidation number represented within a square bracket. This is you study in redox reaction. Okay, so aluminium usually it doesn't react with nitric acid. It forms a protective layer around in it. So we call it as metal passivity. Metal passivity. Are you getting? So how it will be aluminium and boron react with acid and bases. That's we already discussed in earlier class. Okay. Next, after that, reactivity towards the halogen. Reactivity towards halogen. The reacts will directly combines with halogen, means group 13 elements directly combines with halogen will be forming EX3 type of compound. EX3 here. So element plus halogen X will be forming the EX3 halogen, that is plus 3 oxidation state, it is and minus. So EX3 type of compound or MX3 type of compound. But this halogen will be exist as diatomic molecule. So should be balance will be 2E plus. So here only 3 opposite number. So 2 into x, 2 3s are 6, 3 2s are 6, 2e plus 3x2 give rise to 2ex3 type of halide. Okay, halide group 13 halides will be forming. So here given boron react with the chloride of fluoride. So the exceptional, what is the exceptional case we discussed? Except the fluoride that directly combines together will be forming the respective halides. Okay, in the case of the boron trifluoride BF3. Okay, so BF3 is these does not undergoes an hydrolysis. Boron trihalide, boron, all the boron trihalide except boron trifluoride are hydrolyzed to boric acid. Okay, all will give in boric acid, but except boron trifluoride. Why boron trifluoride will not hydrolyzed to boric acid? Because this will be forming like BF3OH minus. It acts as a Lewis acid. It acts as Lewis acid. BF3 having less tendency for the hydrolysis, less tendency of hydrolysis, more force of attraction between them, act as Lewis acid. Act as Lewis acid. Hence, this will be used in the organic reactions. That's very famously known as Friedel-Crafts reaction. FRIEDEL, Friedel, CRAFTS, Friedel-Crafts reaction. Okay. Next, so that is the order. In the case of boron trifluoride, BCl3, and these are volatile in nature, especially boron halides. Boron halides are volatile, highly reactive, and monomeric. They'll be exist as so BF3, boron trifluoride, and BCl3 are gases. BCl3 and BF3 are the gases. Next, down the group BBr3, BR3 is liquid volatile, and BI3 is solid. And particular of the group 13, especially for the boron, that is in the order Bi3 is greater than, BBr3 is greater than, BCl3 is greater than BF3. That is the order. That is the order. Are you getting? This is what we discussed in earlier class. Not only this also react with carbon. They'll be forming respective carbides. Boron react with carbide, B plus C. Okay, will be forming B4C3. B4C3 boron carbide. As like, so aluminum react with the carbide will be forming Al4C3. So group 13 elements react with carbon will be forming the carbide. So C3 is not a carbide. Here B4C will be exist as a one carbon units. Even that's plus one oxidation. B4 is carbon 4 oxidation state. So this will be exist as B4C. Next, in the case of aluminum react with carbon will be forming so aluminum carbide. This is ionic in nature. This is aluminum carbide is ionic in nature and hydrolyzed to give methane, CH4, one of the method of the preparation of the methane. Okay, and group 13 elements react with water. They'll be forming respective hydroxides. But in the case of the boron react with water will be forming or treat with water will be forming respective hydroxides, aluminum hydroxide as well as boron hydroxides. Boron hydroxide is okay in the case of aluminum. So what we need to do, that has to be treated with the mercury will be forming respective amalgam. So why they'll be using Hg when we use in mercury related. So aluminum treat with mercury will be forming amalgamated aluminum. So why this will be using to decompose to separate the ion, decomposition will be easier when the amalgamated compounds means treat with mercury. Okay, we discussed about and the Lewis acid and Lewis bases, both halides like BCl3 and BCl3 is act as Lewis acid, treat with the Lewis base like BCl3 is Lewis acid, treat like Lewis bases, that's NH3 ammonia Lewis base will be forming adduct compound, adduct additional compound, boron for this chloride, and here, so nitrogen NH3, so lone pair of electron, so will be forming dative bond. So this is additional compound, adduct compound. Okay, as like aluminum react with chlorine, it exists as a dimer to attain stability. It also Lewis acid will be forming the bridge structure, aluminum chloride, aluminum again chloride. This is and again aluminum here, the chloride, and these two sides also chloride. This is how it will be exist. These are the reactivity what we discussed. Next, after that, we were discussing about the anomalous properties of the group 13. Okay, so reactivity group 13. Next, anomalous behavior. Reason for anomalous behavior. This due to the small atomic and ionic size, high electronegativity, high ionization enthalpy, and high negative electron gain enthalpy, electron affinity, and absence of d electron. These are the reason why first group elements, y group, the second period means first element in this group shows exceptional behavior. These are the common reason. What are the anomalous properties? What are the anomalous properties of boron? A group 13, it's a covalency. First one is covalency, smaller atomic size, high force of attraction between them. Okay, they show maximum covalency 4. Boron can show maximum covalency 4 because it doesn't only consist S and P. 3 plus 1 is 4 only. Doesn't consist d orbital. So this can show maximum covalency up to 6 because aluminum onwards, boron onwards, aluminum. So they'll be consisting the d orbital. Next, the tendency of formation of multiple bonds in all these group 13, 14. So carbon, single or multiple bond, single, double and triple bond, nitrogen, double bond, triple bond, oxygen, double bond. There will be tendency of formation of multiple bonds. Okay, that is the anomalous behavior. And the reactivity. First member of each group in the P block are less reactive than the other members. This is due to absence of the d orbital. Okay, these are the anomalous properties of the boron, and similar to the boron, carbon, nitrogen, oxygen almost will be having the same anomalous properties. Next, some compounds of boron. Now, actually, we need to discuss from here some compounds of boron. Boron compounds we need to discuss. Okay. First one in that borax, okay. On the composition of borax, the formula of the borax, it's very familiarly called as tinkle, TINCAL, tinkle. So we studied that, that is the ore, one of the ore. So borax here this is not given, it means it's not clear because Na2B4O5 OH molecule will be here, and when we separate this one will be having a formula. What will be its formula? Na2B4O7 10H2O. This is the formula of borax. Formula of borax. This is also we call as, what is Na? Sodium. What is B? Boron. And O is oxygen. This is borate. This is sodium. This is 10 water molecule. The name of this compound is sodium tetraborate, 10 water molecule, no, decahydrate is the name for the borax. Name of the borax is sodium tetraborate decahydrate. Sodium tetraborate decahydrate, Na2B4O7 10H2O. This can also be write like this: Na2B4O5 OH 4 times 8H2O. Okay. not only how to prepare this, how this will be prepared. So Na2B4O7 plus this is the reaction. They here we not given preparation. So preparation of Na2B4O7 from the colmanite calcium ore, that is Ca2B6O11 colmanite ore. This will be treated with sodium carbonate Na2CO3 will be forming Na2B4O7 Na2B4O7. This is what we call as borax, along with the formation of calcium carbonate CaCO3 plus sodium metaborate to NaBO2 to Ca, and then to Na2CO3. This is the balanced equation. So NaBO2, what is the name of this compound? Sodium metaborate. Sodium metaborate. What is this? Is calcium carbonate, and this is borax Na2B4O7. Not only this, borax, it also prepared from the boric acid. Okay, boric acid, orthoboric acid, you know the formula. H3BO3 is called orthoboric acid. Orthoboric acid treat with sodium carbonate Na2CO3 and with a small quantity, and will be neutralizing with this boric acid. Sodium, what will borax is neutralizes with soda ash Na2CO3, will be getting Na2B4O7 borax with a formation, liberation of carbon dioxide CO2 gas, and formation of water molecule H2O. Balance this 6H2O and 4H3BO3. So there is a balanced equation. So what is this? NaH3BO3. H3BO3 is called is what? Orthoboric acid or boric acid. Boric acid. What is Ca2B6O11 is called colmanite. Colemanite, colemanite or colmanite ore. Okay, so treat with Na2CO3 sodium carbonate, will be getting borax, or this H3BO3 boric acid treat with sodium carbonate, soda ash, will be getting Na2B4O7.